right, exceptions then. Um, we will start by talking about different types of errors that might occur in your program. I mean, when your program runs, there are, of course, expected errors. I mean, things like, okay, so the user has entered a password that's too short. You need to at least have like 8 characters or something. Uh, it could also be, I mean, more. That's a typically, validation error. We also have more business oriented errors that are expected to happen. Like, okay, so the user tries to withdraw 5,000 kronors at the ATM machine. I mean, there is a daily limit. I think it's I don't know, maybe 3,000 or something. So that's a business rule. Also, I mean, yeah, I mean, it could also be trying to withdraw more than your balance and so on. And I mean, typically we solve those types of errors by if statements. So if amount is larger, if withdrawal amount is larger than balance, then we typically we prompt the user for better input and just repeat it. But I mean, it's not always that easy either. It could be, I mean, typically we don't have like all our code in main. So I mean, we have like, okay, so we have a function. Oh, sorry. What happened? So we have a function calling a function, calling a function, calling a method in a, and I mean it's many levels deep, and I mean it could be in this function the UI is enter amount like this. But then I mean we call a function called do withdrawal or something. I mean, yeah, we should probably input it as well, of course. And I mean in this example, let's make it easy by using ints. I mean in this example we are calling into another function, and in that function we do something, and it will create an object of type account, and we will, you know, so the error might occur many levels down. So we have like, like this. Like function A is calling function B, A is calling function C, is calling function D. And then in function D we find out there's an error. You're trying to withdraw too much money. Then I mean the problem lies here. The problem lies here. Or the remedy, the fix for the problem is you have to enter the amount again. So we need to propagate the error down, actually from here, down all the way to function A then. I mean, we could, of course, have every function return, I mean, true or false, or an error code. That's one way of doing it. So, I mean, do withdrawal, we could do like if do withdrawal is equal to false. Sorry. Actually, if it's equal to true, then we could break, and we might have an infinite loop like this. Okay. but I mean, then we have to we have to implement. So each function returns true or false. But I mean that there are functions that already do return something. I mean, a function, it could return, I mean, a list of transaction already, or on float or something. So I mean, it's not that easy to also return. It's not so easy to say you should always return, true or false, or an error code or something. It's not so easy. The structure of our program won't be that good then. Also, we do have functions not being able at all to return an error code. Constructors, we will, I mean, a constructor, we will talk about object-oriented programming later on. We have a class, and we have a special function called a constructor, which is called when we new such an object. when it's created, and we can never return true or false or something. We could not return anything. A constructor of this structure may not return a value. So I mean, it's not even possible to always try to return an error code. Also, it's certainly is possible that the coder simply ignores the error value. I mean, have a look at this. Let's say the coder is not. I mean, we could just do this. I mean, we could ignore. The programmer might not even know that he or she is supposed to look at the error code. Or there might be a range of error codes. I mean, there could be multiple types of errors. It could be an enum or something. And it's so easy to forget to check for a certain error. So there we have exceptions. Instead, we have exceptions. Exceptions can't be ignored. I mean, they are handled, or the application will crash. And actually, it's not so bad. I mean, it's better for an application to crash than to, I mean, swallow an error and move on in an invalid state. It's better to crash than to, I mean, to continue and suddenly you're able to withdraw any amount at all, and I mean, there will be problems. So it's better to often it's better to crash the application instead of not handling the error at all. And exceptions have the ability, I mean, it's built into it, the ability to, I mean, we could raise, or should I say throw an exception up here, and we could handle it down here, and we don't have to, I mean, we don't have to send it like in a return value from the function. So it's another way. It's a complete other way of transferring state, or an error from one function down the stack to another function. And I mean, exceptions are standardized. We do have exceptions in like every single language there is. Not to say exceptions aren't controversial, because they are. There is a cost with exceptions, and I mean, I will show a link later. I mean, there are first of all, there are programming languages, modern languages, where they decided to not have exceptions at all, because it's often misused, and there are a lot of problems involved with exceptions. However, also I mean, I will show you a link to the C++ policies used by Google internally on Google on their policy on how to code C++ when you are an employee at Google and you're not supposed to use exceptions. But I mean, that's an opinion. I will show you how exceptions work. Because we will use exceptions. We don't have any policies like that. So okay, let's actually, yeah, why not? Okay, I will do like this instead. So let's have a vector. I mean, that's the school example of. Let's have a vector. So a vector is I mean, it's a wrapper around an array. I did show you like the first day how arrays are. I mean, they don't have any range checks, but a vector, that's an abstraction over an array. It's a class and it has it has range checks whenever we try to access anything. So let's do it. Let's value equals to is it at yeah, it's at, okay, 12. Okay, so I think you will understand this should probably crash. So let's see out the value as well. And we could also see out we're done like this. Okay, let's have a look. Let's try it actually. So let's run this like this. And okay. So what happened was terminate called after throwing an instance of stood out of range. So there is something is being thrown, and it's an exception that's being thrown. So something unhandled, something extraordinary, something we haven't expected has happened. And the program has crashed. Why has it crashed? Because we are not handling this type of error. Okay, so let's let's do it like this. I will call this function B then, just because I mean we have function A, function B. So let's just move all of this into function B like this, and let's call function B from here. Okay. So the problem was we didn't handle the error. I will start up here. What we can do is we could protect a certain code block by putting it inside a try statement. So we are telling the compiler or the CPU, please try to do this. And here's the thing. If an error of type out of range happens, I need you to catch it. So if something happens, if this happens, if an exception is thrown of type out of range, I want you to run this code block actually I will do a like this. Okay. And what we're saying is, okay, sorry, I'm missing a curly bracket. What we're saying is, okay, I want to catch that exception. So please don't crash the whole application. I will handle the exception and I will try to recover from it. So the thing is, there are errors, there are exceptions, and we could try to recover from it. I mean, what we're saying here, yeah, I understand that. I mean, if this type of error happens, I know how to recover from it. And I will handle it, and it's not like the end of the world, so you shouldn't, I mean, crash the application. I just want to continue. So we can do like this. No, let's just yeah, let's run it. Let's run it. Okay. And what happens now is, as you can see, we're on this line now. I mean, it did run that function, and it tried to get that item by index 12. There was an exception thrown. I mean, we did see that before, but that exception was of type out of range, so we did end up here, and it says an error happened. Yeah, that's us saying that. E.what is, I mean, that's information for us, telling us what was wrong. I mean, it and as you can see, it's pretty self-explanatory. So it says, okay, so you try to it's a range check, and n is 12, and it's larger than size, which is 1. So I mean, that's how exceptions work. And if we were to do this in a more I mean, let's do like this instead. So the user enters an int, and we could then have an infinite loop, and we should of course create the vector outside of it. So we have so we have a vector or something, and we're inputting an index. We're trying to get the value at that index, and if it succeeds, we will do a return. So we will leave the function. All right. Otherwise, I mean, it will loop, and we will have to. I mean, that's just an example on how to actually recover. I mean, okay, so you enter something bad. Let's try again. Okay, so that's one part of exceptions. Another thing is that an exception could happen in this function. Let's actually do a function C instead. Function C, and I will go back to. Go back to this. Oops. Numlock as usual. Okay. So we have function C. And once again, I mean, if we run this, it will of course crash. So, but as I said, an exception could be propagated from a function down to an exception handler which handles the specific error. So let's have a look at that. I mean, we could, when we, there will be an exception here, right? But we could handle it in this function. So, I mean, we could try to call the function, and we could just copy and paste it. And we could select to handle it down here instead. So no matter how many levels down, how many function calls, when an exception happens, what we say is the stack will unwind. It will look down the stack until it finds a handler that will handle this specific error. If it doesn't find a handler for this specific error, it will crash, so the application will end. But whenever it finds an error, an handler, I mean the stack will unwind, meaning all allocations on the stack will be returned to the system, and the good part of it is it's built in, so all destructors are called. I mean, let's do this as well. We have a class, yeah. So let's try to, let's try to create. Let's try to create. Actually, I think I need to pass a string. I don't remember. Yeah, okay. So yeah, I mean it takes string. So as you can see, we have, it says constructing, distracting, and let's actually, yeah, let's select this. Also, let's create it. Let's create it up here. And what I've done with test class is we have a constructor, and whenever the constructor is called, it says, I'm constructing right now. And we have destructor, and the destructor, that's so important to have objects sort of delete themselves, and delete not just themselves but also the resources an object has created need to be returned, and we use the destructor for that. So whenever an object goes out of scope, we'll talk about that later, for how long does an object actually live. The short answer is it lives inside its code block. So this object will be constructed and it will be returned when we leave this code block. It will be distracted. But I mean this one, it feels like it will never be returned, or will it? Because when we come to this line, it will. What we said here is we will not leave the function this way, right? Because this line will never be called. As soon as this happens, it will be an exception will be thrown, and therefore the next line will not be this line, but the next line after this will be down here. So we are kind of not leaving this code block as we're supposed to. But the thing is, what I want to show you is destructors are being called when the stack is being unwound. Let's just run it and I will show you. Okay. Okay. So what happens was constructing this object, yeah. constructing this object then, and we got to this line. On this line, there was an error, right? There was an exception, which means this line should be the next line. But as you can see, it happens here, right? And before that, this object is really being destructed. And also, this object is also being destructed. Yeah, because I mean, when we when we are calling function C, we are still in this block, right? But when we then call into this block will be left, and therefore all objects, and this object is created in this scope, in this block, so it will be destructed. So I mean, there we have it's really it really works almost regardless. I will talk about it later. As long as we use the stack. I mean, there is a possibility to create things on the heap with new. And now we have a problem, because this one will never be destructed. This will be a memory leak. But I mean, that's not how we're supposed to do it. When we code C++ from C++ 11 and 14, and I mean modern C++, we're not supposed to do new. We should never ever use new. We should always use make shab, which will create an object. So this will be actually this will be an share pointer, yeah, like this. So I mean, what is a smart pointer? I meant smart pointer. A smart pointer is a pointer that's there is a pointer inside it, but there also a stack allocated part which will then have a destructor that I will talk about it later. So I mean, as you can see, exceptions really work. It's possible to do pretty much anything. Okay, so this was part 1. In part 2 of exceptions, I will talk about what can we throw. As you can see, here we have exception instead of out of range. We will look at the exception classes inside the standard library. But that's for the next video.